All right, good morning. I'm James Morris, and this is Group 18's Deliverable 3 Part 1 Proposal Presentation. The group consists of Ricky Ray, Robert Hayworth, James Morris, and Jesse Torres. Slide 2, Problem Definition Statement. Team must design 4 instruments, including a string, pipe, and percussion with at least one repeating, capable of playing the notes in the song Ode to Joy. Each instrument will be assigned to play at least one of 4 voices: high, the mid, and the low. The mid is consisted of an upper and lower octave. These instruments must all collectively fit within a stage box of 2 cubic feet and not exceed 10 feet of piping and or 6 feet of guitar string, be visually appealing, and not exceed a budget of $15 each on construction. The team goal is to provide simple, affordable, and elegant design solutions for the requirement designs. First instrument, pan flute, slide 3. Design is comprised of a series of straws cut to specific length and closed on one end, taped together for consistency and descending length. When blown into the tube, the air will resonate through the pipe from one end to the closed end, creating the frequency and or sound heard. The design is simple and relatively easy and cheap to produce. The estimated budget for the initial production is $2 for bare materials, and further funding can go towards improving tubing materials for durability and aesthetics. Slide 4, general idea sketch of what a pan flute would look like, and the mathematical formula used to construct the pan flute is as follows. Frequency is equal to the velocity of the medium, or air, the speed of air over the wavelength, which we can rearrange to find the length of each tube for each note the length would be equal to the velocity over 4 times the frequency. And that is the pan flute.
Ricky Ray. Our second instrument will be a bottle pop. It's comprised of a series of plastic bottles filled with varying levels of water, and when you blow on them, it will create a resonance, which would give you a note, depending on how much water is in it. It'd be easy to build, cheap, easy to operate. Should be about $5 to build, and then the rest of that could be used towards just purely aesthetics. If you'll note on the next slide, slide 7, one bottle would be representing each note. So every note you need, you would add a different bottle. And up to 9 would be 22.5 inches. So for a 2 foot by 2 foot box, that'd be about the max. But you could also hinge it if you need to collapse to save some space. We originally thought this was maybe a one end closed flute or a pipe, but it's actually got its own equation for a cavity resonance, which, if you'll note on slide 8, is velocity over 2 pi times the square root of the area of the opening divided by the volume of the cavity multiplied by the length of the opening. And if you were to look at our decision matrix on slide 9, we weighted it with the pop designs, and it did not do well in the visual appeal, but it was phenomenal in cost effectiveness.
Jesse Torres here, introducing the harp concept for our string instrument. Design be similar into an actual harp in regards to the amount of strings being processed through on the instrument. The only thing is we'll be adding a tuning mechanism to increase the numbers of pitches and notes we will be able to hit with design. Basically, this instrument will be reused metal and reclaimed, while also maintaining a $10 budget, and cosmetics are not included in the budget. As you can lead into the next slide, slide 11, it's a rough design of what comes to mind on the design. Multiple bands, string, created by screws or bolts, and it will be small yet functional. Slide 12 is going to go into the actual math behind the harp concept. As you can see, frequency is going to go into the equation 1 prior into the module, and this will be presenting us into the next slide, slide 13. It's going to give us the criteria we use to dictate this as the winning design. Very small, functional, and it numbered well on the actual design process in the matrix.
Okay, I'm Robert Hayworth. I'll be going over the percussion instrument. For this, the glockenspiel was selected. The design consists of copper pipes supported on wooden bars. held in place by rubber bands, which enables them to still vibrate when struck with a wooden mallet. The design is really easy to build, easy to operate. You can play as many notes as you have pipes. Estimated budget is around $15. On 15, we have the design concept. As noted, 1, 2 for each note. On 16 is the formula previously used in the acoustics assignment. Equations 9 and 10 for this. And in conclusion, we feel that all our instruments meet all the specifications and criteria for this assignment, well under budget, and will all fit in a 2 square foot box. On 19, we have what references we used for the project. Thank you.